All right, welcome back. We're going to go ahead and continue our final exam review here. We're going to work on problem number 2. This is Bernoulli Equations. Okay, let's see here. So let's just run through these. Okay, so let's see what we got. I got problem number 2, 2a. We've got a t squared y tick plus 2t y minus y cubed is equal to 0. First thing we're going to do is we're going to put this thing in standard form. That involves putting the power of y, the y to the n, to the right-hand side. And then we're going to clean off our coefficients. Okay, so we want a 1 coefficient on the differential. Okay, so let's go ahead and do that. So that's going to give us a y prime plus 2, and I'm dividing by t squared, right? So that's going to be a 2 over t, y, and that is equal to, right? We have 1 over t squared. Let's go with t to the negative 2 here, y cubed, right? Yeah, that's how I did this. And we notice, we say, hey, wait a minute, it looks almost like a linear, first order linear with integration factors, except this right-hand side has a y to a weird power. Okay, not 1. So what we're going to do is we're going to let v, okay, or use any letter you'd like, but let v equal to y to the 1 minus 3. That is the appropriate thing to do here. Okay, it's the appropriate substitution. So once I have this, right, we have v is equal to 1 over y squared. It's often very useful to like do a couple of substitutions or do a couple of iterations of this, permutations of this. So what we're going to say is something like, well, how about y is equal to v to the negative 1/2, right? If I cross multiply and take the square root of both sides. Okay. When you make substitutions in calculus, the first thing you want to do, or one of the earliest things you want to do, is you want to take its derivative. So it's going to be negative 1/2 v to the negative 3/2 chain rule times v tick. Okay. And because I've got a y cubed here, I might want to know what y cubed is, and that's v to the negative 3/2. All right. So I think I've got a y equals, so we have that substitution covered. We've got y cubed, we've got that substitution covered, and we have our dy, we have that substitution covered. So now we're going to substitute. Okay. And what do we have? We have negative 1 over 2 v to the negative 3/2 times v tick. Okay. Plus 2 over t. Okay, what's y? Y is v to the negative 1/2. Okay, and then that's t to the negative 2. What's v cubed? V cubed is v to the negative 3/2. Okay, next thing we're going to do is, it's going to be guaranteed to be first order linear once we get done massaging all of this. So again, we have to put this in standard form. Okay, which means I'm going to multiply by negative 2, because that will take care of my 1/2. V to the 3/2, because that'll make that an exponent of 0. Okay, and I think that, yeah, that'll do it. So we're just going to multiply by negative 2v to the 3/2. Okay, so negative 2v to the 3/2 times this whole mess. Okay. Okay. And e to the negative 2, v to the negative 3/2. So what's supposed to happen here, right? Everything goes back to a 1, so we just have a v tick. Okay. Plus we have 2, actually we have a minus, don't we? We have a minus 4 over t. We have a minus 4 over t. Okay. We have v to the 3/2 minus v to the 1, right, times v to the negative 1/2. So 3/2 minus 1/2 is 2/2, so we just have a v here. Okay, and that is equal to negative 2 t to the negative 2. Right? And then 3/2 minus 3/2, oh, that's v to the 0, so we're set. Okay. Now, this looks a lot like a first order linear problem. We have to go ahead and find our integration factor. So we have rho, right, that's rho, is equal to e to the negative 4 over t integral. Okay. And that is going to be e to the negative 4 ln t, which is e to the ln of t to the negative 4, which is t to the negative 4, right? So let's go ahead and we have to multiply 3 by this. Okay, so we have t to the negative 4 v tick, okay, minus, well, we're going to say this is minus 4, negative 4 minus 1, right? That's going to be t to the negative 5 v, and that is equal to negative 2 t to the negative 6. Okay, so thankfully we don't have an integration by parts there. I really recommend, make sure, okay, when you put these two together, okay, if I took this derivative implicitly, would I actually get the thing above me, right? That's going to be a negative 4 t to the negative 5, yes, okay. So double check to make sure that this product will actually works out for the line above it, okay. Because if you don't, it's going to get a little messy, and you really, you know, that's how you tell whether or not you make the right substitution. Because I'll tell you, memorizing like all these little substitutions to deal with, it's, you know, it's not easy. Okay, there's a lot of substitutions to remember. There can be, all right. So just make sure you got it in the right order, and you have like little checkpoints to make sure it actually works. So here we go. We have t to the negative 4 v equals, and we're integrating both sides here, right? So we're integrating this part now. So it's going to be negative 2 t. We're adding ones to negative 5 over negative 5 plus c. Okay. So we have v, right? Well, let's clean this up. T to the negative 4 is equal to 2/5 t to the negative 5 plus c. We're going to multiply both sides by t to the 4th. Okay, so we have v is equal to 2/5 t to the negative 1, right? Because 4 minus 5 is going to be negative 1, plus c t to the 4th. Okay, now that's my v. We really want this in terms of y, right? So we go back up here and we look up, well, y was equal to v to the negative 1/2, right? So recall y was equal to v to the negative 1/2. This is v. Okay, so y is equal to v 2/5 t to the negative 1 plus c t to the 4th to the negative 1/2, and you're set. Okay, they didn't give us an initial condition. We did solve explicitly for y, so we should be all set. We're all good, set and done here. Okay, let's look at part B. Okay, this is, I think, 2b here. So let's see. I wrote this down so I can not have to deal with this. So this was y tick plus 2 over x. Y is equal to y to the 1/2. Did I really make it that easy? I did. All right. There's a minus here, but again, we're going to put this in standard form. So we had a minus y to the 1/2. First thing we're going to do is push it over. Okay. One moment here. There we go. All right. So again, this is nice because it's pretty much started off in Bernoulli. Okay. Again, we have a y to some power that isn't 1 here, so it is Bernoulli. So again, we're going to go ahead, we're going to have v is equal to y to the 1 minus 1/2, and we get v is equal to y to the 1/2. Okay, so again, right, y is equal to v squared. All right, so that's good to know. And we know that dy is equal to 2v times v tick, chain rule. Okay, so I think we're ready to do substitutions here because we have our y to the 1/2 is equal to v, we have y is equal to v squared. So we have all of our little substitutions in place. So here we go. We've got 2v times v tick plus 2 over x, and then we have y, which is going to be v squared, and that is equal to v. Okay. We're going to multiply both sides by 1/2, 1 over 2v. Okay, let's do it that way. So we're going to multiply both sides by 1 over 2v. So let's see what we have here. We have v tick plus, well, the 2's cancel, so we just have 1 over x now. Okay, v cancels with the v squared, so we just have a v here. Okay, and is equal to 1/2 on the other side. All right, perfect. First order linear. Let's get our integration factor. Okay, so that's going to be e to the integral 1 over x dx, which is going to be e to the natural log x, which is just x. So we're going to multiply through by x. So we have x v tick plus 1v equals to 1/2 x. Okay, double check, make sure that x derivative of xv really is what this is. I think that's pretty obvious. And we have 1/2 x over here. Integrate both sides. So we're going to integrate the derivative of xv. Okay, integrate 1/2 x. Get the semicolon. So we have xv is equal to a 1/4 x squared plus c. So v is equal to 1/4 x, right? Divided both sides by x plus c over x. What the heck is v? Well, you remember that v is equal to y to the 1/2. Okay. Or y is equal to v squared. Okay. So we're going to have y is equal to v squared. V is 1/4 x plus c over x squared. Right? There you go. Okay. And I think the last one, because that'll take care of that. Okay, so let's see our final exam outline. We got x, y squared, y. Oh, I want to remember this one. Okay, so here we go. We have x, y, so y squared, y tick, was y squared, equals 2x cubed plus y cubed. Okay, so let's go through. First thing we're going to do is we're going to try to put this thing in a standard form. So we're going to divide by x, y squared. Okay, so we have y prime is equal to, well, we're going to have an x over an x, right? So that's going to be an x squared and y to the -2, right? So there wasn't a y in this term, so we have y to the -2. Plus, and then here we're going to have x to the -1, right? X to the -1. And then we're divided by y squared, so we just have a y here. Right? So let's go ahead and fix this together. So we have y prime minus 1 over x times y is equal to x squared y to the -2. Okay, there's my standard form. Say, wait, look, we've got a power that's not a 1, so we have Bernoulli. Right, so we're going to have v is equal to y to the 1 minus -2. Okay, careful with the signs on these. It can be really, if you're going to make a mistake, it's right here. Okay, so v is equal to y cubed. Okay, so here we have y is equal to v to the 1/3 power, right? Okay. And dy is equal to 1/3 v to the -2/3 times v tick. By the way, y to the -2 is equal to v to the -2/3. Why do I care about that? Because I'm going to have to make a substitution involving y to the -2. Okay, so let's go ahead and fit this business in here. Okay, so here we go. We have 1/3 v to the negative 2/3 times v tick minus 1 over x. What's y? Y is equal to v to the 1/3. Right? That is equal to x squared v to the negative 2/3. Okay, just a straight substitution, replacing all of my y's and y-related items with v's, v-related items. Okay, we are going to now multiply by 3v to the 2/3, right? Because that'll clean off this first coefficient here. So we end up with a v tick minus, and then we have a 3 over x. Okay, now here we have v to the 1/3 times v to the 2/3. That's just going to be v. Okay, and we're going to have an x squared v to the negative 2/3 times v to the 2/3, right? That's just 1. So again, we're back to this first order linear. Okay, so we've got it in the position that we wanted to do this. Now we can go ahead and apply our integration factor. So remember, integration factor is equal to e to the negative 3 over x. Okay, that's equal, integral. Okay, that's equal to e to the negative 3 natural log x, which is e to the next natural log of x to the negative 3. This was one of the biggest mistakes people made. Okay, so just be real careful about this, and we're going to be multiplying by x to the negative 3. Okay, so here we go. We have x to the negative 3 v tick minus 3 x to the negative 4, right? It's on the bottom, so it's a negative 1. Negative 1 plus negative 3, negative 4. This is equal to 3. Looks like 2 minus 3 should be x to the negative 1, yeah? Okay. Double check to make sure there's a v here. Okay. Is this the product rule, right, of x to the negative 3v? Okay. Again, I think it's pretty obvious that that is the case, but this does give us a checkpoint to see, have we done all of our substitutions and integration factors correctly up to this point? Because if we haven't, this product rule is not going to match. Well, it might. We still could have made a mistake, but there's a good chance, right, that this is consistent with the thing before it, which is consistent with the thing before it. So we're doing pretty well here. Okay. So let's see what we got here. We got 3x to the negative 1. Okay. Did I really forget to do that? Yeah, it looks like I did. Okay. All right. Go ahead and take the integral both sides. So we end up with x to the negative 3v. That equals 3 natural log x plus c. And then what we're going to do is we're going to multiply both sides by x cubed. And we'll have v is equal to 3x cubed natural log x plus cx to the 3. Okay. And going back to our original substitutions here, right, we had v was equal to y cubed, right, or y was equal to v to the 1/3, okay, recall. Y was equal to v to the 1/3. This is v, so what we're going to say is y is equal to 3x cubed ln x plus cx cubed raised to the 1/3. I guess we could be a little clever and we could have factored out the x cubed, so we could have had x 3 natural log x plus c to the 1/3 power. Okay. And there we go with, that was it. Yeah. So there we go with our Bernoulli equations. That was pretty good. So again, just make yourself little checkpoints along the way. That way it keeps us from like doing a weird substitution or making sure that we actually did substitute correctly. We did find the correct integration factor and everything there. Okay, so I will see you in the next problem.